So in problem number 3, we have another question revolving around the mean value theorem. And I'm going to ask the same questions I asked before. Is f continuous on the interval in question, which is the closed interval from 0 to 4? Yeah. Is f differentiable on the open interval from 0 to 4? Well, it's a polynomial. Polynomials are differentiable everywhere? Okay. So we now know, we have evidence that the mean value theorem does apply in this case. So the mean value theorem says that I should be able to find a c such that f prime of c is equal to f of 4 minus f of 0 over 4 minus 0. So what is f of 4? 4 cubed is 64. So 4 cubed is 64, 64 thirds. I don't like this problem already. All right, 64 thirds minus 2 times 4 squared, which is going to be 32. 32 is spelled 32. All right, plus 12 plus 4 minus the value of this function at 0, which is 4. And we're going to divide all of this by 4. So this 4 and this 4 cancel. Negative 32 plus 12 is 20, negative 20. So we have 64 thirds minus 20 all over 4. Common denominator between 64 thirds and 20 is going to be thirds, so 64 thirds minus 60 thirds over 4, which is going to be 4 thirds divided by 4, which is the same thing as multiplying by 1/4. Okay, it looks to me like the average slope is 1/3. What about the instantaneous slope? Well, we'll have to take the derivative of this. F prime of x is equal to x squared minus 4x plus 3. So f prime of c is going to be c squared minus 4c plus 3. So this is equal to 1/3, or c squared minus 4c. And I'm going to subtract the 1/3 from both sides. That's 9/3 subtracted by 1/3. That's going to be plus 8/3 is equal to 0. And we want to know the sum of the two values that make that sentence true. The sum of the two values that make that sentence true. And that's going to be, let me do some quick working here. Negative 2b over 2a. That value is going to be negative 2 times negative 4 over 2. That sum is going to be 4. And you're like, whoa, how did I do that? Are you ready? Because this is really cool. This is really cool. This is not calculus, but this is really cool anyway. All right. I'm looking at this quadratic, c squared minus 4c plus 8/3, right? And I don't see a factorization off the top of my head. Agreed?
Yeah.
Michael?
How did 3 change to 8/3?
I had 3 equals 1/3, and I subtracted 1/3 from both sides. So don't think of that as a 3, think of it as a 9/3 minus 1/3 for a total of 8/3. All right? So again, I'm looking at this quadratic, and I'm like, oh, I'm going to have to use the quadratic formula. Now notice I didn't ask you what is the sum. It didn't ask me what are the two values c. It asked me what the sum of the two values are. If you don't mind, I'm going to erase this. Come on, erase. There we go. And I'm going to basically say the two answers there are going to be negative b plus negative b plus the square root of b squared minus 4ac all over 2a. Are you agreed? And the other one is going to be negative b minus the square root of b squared minus 4ac all over 2a.
So they cancel.
So when I add them together, what happens to the square root part? They cancel out. And what do I get as the sum? Negative 2b over 2a. So I took the value of a, which was 1. I took the value of b, which is negative 4, and I plugged it into what is the sum of the two of the two roots. Now I do have to be careful. Are we sure that both of these roots actually would fall in the interval from 0 to 4? Do we know that's true? Because maybe my answer is wrong. Maybe one of these roots falls outside. Maybe? Well, let's just take a quick look if we plug this in. Negative 4 plus or minus the square root of 16 minus 4 times 1 times 8/3. All over 2. This square root is going to be 16 minus 32/3.
When did you find that a was equal to 1?
Well, I'm reading it. The a is the coefficient on the c squared term. 16 minus 32/3. That's 48/3 minus 32/3. That's 16/3, which is how much?
4. No.
I thought it was 12. So that's more than 4.
That's more than 4. Okay, but when I subtract negative 4 by that value, ooh, so on the positive version of that, I get a value that's in between 0 and 4. But when we go negative 4 minus another value, yeah.
What is it? Negative 4 plus.
So there's only one value that satisfies the mean value theorem in this case. And it's going to be negative 4 minus the square root of 16/3 over 2.
Mr. Fedor,
Yeah.
wouldn't it still be a positive 4 even when you subtract it? Because you take the opposite b?
Oh, it's because right. All right. In which case, if that's the case, since this is not, the square root of this is not bigger than 4, we never go to the negative range. So, no. Yes, we're good. We're good. So the sum is 4. All right.